The question we are going to discuss is distinguish between center of mass and center of gravity. Center of mass, center of gravity. The point at which the entire mass of the body is supposed to be concentrated. The point at which the entire weight of the body acts. Center of mass is independent of acceleration due to gravity. Center of gravity depends upon acceleration due to gravity. Center of mass lies inside or outside the body. Center of gravity always lie inside the body. This concept is used to describe motion of body. This concept is used while dealing with stability of body. Next we are going to discuss vector product, properties of vector product. The vector product of two vectors a bar comma b bar with an angle theta between them is a bar cross b bar equal to ab sin theta n cap. Here n cap is the unit vector normal to the plane of a bar comma b bar. Properties of vector product. Commutative law does not holds good. That is, a bar cross b bar is not equal to b bar cross a bar. Distributive law holds good. That is, a bar cross b bar plus c bar equal to a bar cross b bar plus a bar cross c bar. Vector product of two parallel vectors is null vector. I bar cross I bar equal to j bar cross j bar equal to k bar cross k bar equal to 0. Vector product of two perpendicular unit vectors is a unit vector normal to the plane of the given vectors. Example, I bar cross j bar is equal to k bar, j bar cross k bar equal to I bar, k bar cross I bar equal to j bar. Examples for a vector product is torque tau bar is equal to r bar cross f bar, velocity v bar is equal to r bar cross omega bar. The next question we are going to discuss is write the equations of motion for a particle rotating about a fixed axis. Consider a body rotating with constant angular acceleration alpha. The equations of motion for the rotating body are 1. Omega equal to omega naught plus alpha t. 2. Theta equal to omega naught t plus half alpha t square. 3. Omega square minus omega naught square equal to 2 alpha theta. 4. Theta n equal to omega naught plus alpha times n minus half. In the above equations, omega is angular velocity after t seconds, Omega naught is initial angular velocity, alpha is angular acceleration, t is time taken, theta is angular displacement. The question we are going to discuss is define angular velocity, derive v is equal to r omega. Angular velocity omega. The rate of change of angular displacement is called angular velocity. Angular velocity omega equal to d theta by dt. Consider a particle moving along the circular path of radius r with an angular velocity omega. Let the particle move from P1 to P2 in time t seconds. Therefore, from the diagram, angle equal to arc by radius. From the diagram, angle theta equal to arc s by radius r. From that we get s equal to r theta, where s is linear displacement. Differentiating the above equation with respect to time, we get ds by dt equal to r d theta by dt. Therefore, v equal to r omega, since ds by dt is equal to v and d theta by dt is equal to omega. The next question we are going to discuss is define angular acceleration and torque. Establish relation between angular acceleration and torque. Angular acceleration alpha. Rate of change of angular velocity is called angular acceleration. Angular acceleration alpha equal to d omega by dt. Torque tau. The turning effect about an axis of rotation is called torque. Torque tau equal to dl by dt. That is rate of change of angular momentum. Relation between angular acceleration alpha and torque tau. If I is the moment of inertia of rotating body and omega is angular velocity, then its angular momentum L equal to I omega. Differentiating the above equation with respect to t, we get dl by dt equal to I d omega by dt. We know that dl by dt is equal to tau and d omega by dt equal to alpha. Therefore, tau equal to I alpha.